I'm Sally Traxler, and I'm the director of the Droneport Network. So today we've been talking about everything from state strategies to operations to operating drone ports around the country. But all of this depends on safety. To be able to integrate into the national airspace, we need to do so safely. So I'm really pleased to have with us today two colleagues that we get to work with a lot through the UAS Cluster Initiative in the great state of Oklahoma is Cratley Epperson. He is the CEO and founder of Viability Aerospace Systems, and Jamie Jacob, who is the director of the Unmanned Systems Research Institute at Oklahoma State University. As they said this morning, this is the other OSU. Cratley, I'll turn it over to you.
All right, thanks, Sally. Great to be here. We're really excited to make this presentation. As Sally said, I'm Cratley Epperson. I'm the CEO and co-founder of Viability Aerospace, and we are a technology company. We are headquartered in Oklahoma City, but we actually have people across the country, and we build safety systems for unmanned aircraft based on a couple of NASA patents that we have licensed, and these include multi-sensor systems that help unmanned aircraft to deconflict themselves and stay the proper distances from manned aircraft. We do this both on the ground and increasingly in the air with those sensors. So we're going to be talking a little bit about that today. And our session is about how you use drone ports to develop new technologies and how you test those technologies. So I'm here with Jamie Jacob. As Sally said, he is at Oklahoma State University, and he is the director of the Unmanned Systems Research Institute, which we work closely with and have specific projects with that we'll talk about a little bit. And I'd like, Jamie, if you can introduce yourself and tell us a little bit about your institute.
Sure, thank you. As both Sally and Cratley mentioned, my name is Jamie Jacob. I'm the director of the Unmanned Systems Research Institute here at Oklahoma State University. We've had an unmanned aircraft flight test station, aka Droneport, for about the past dozen years, primarily focused on research and development applications, trying to push the boundaries for beyond visual line of sight and safe navigation into the national airspace. So I've had the pleasure to work with Cratley the last couple of years on projects related to developing and testing his technology to be able to make this dream a reality. So with Cratley, I'll turn it back over to you.
Sure, absolutely. So we're going to talk about how you use drone ports to develop new technologies, what that means in our context, and we have an example project that we're going to probably focus on, but we'll talk about a variety of projects. And this is really hands-on, so we've got photos from some of our recent flights. I'm going to share a screen that will allow us to share some of these photos. So we'll get started here. Oh, and by the way, I was told I should mention this. Tomorrow at 9:45 is my full presentation on the recent 18-mile autonomous small UAS flight that was conducted with Jamie's team at the Unmanned Aircraft Flight Station, the drone port that we're going to be talking about. And that's really a deep dive discussion into the system, safety system setup, and the details of that project. And so hope you make it to that event tomorrow. That's part of XPONENTIAL. So this is a photo. Sorry, it's a little fuzzy, but this is a photo of the facility. And I'm going to let Jamie talk us through what we're looking at here so we can
understand. Yeah, this is our unmanned aircraft flight station. It's located about a dozen miles east of Stillwater. So it's located on a section of land that we currently lease from the state. So the primary runway that you see there, is, to give you a sense of scale, is 600 feet long. So that provides us the capability to do rather large, fixed wing flight testing. It includes a hangar as well as a ground control station, and plenty of space for us to be able to bring in supplementary facilities. Typically mobile ground radars and other ground test facilities for us to be able to flight test. I believe Cratley will be going over the corridor there, but we typically operate through a number of COAs, or certificates of authorization, through the FAA for our flight testing. That includes the COA that you see here, which is our BVLOS corridor, which extends from the southern portion where you have that unmanned aircraft flight test station to another flight test facility we have located just west of Pawnee that you see there. So that corridor is primarily 1 mile wide. And so we have COAs on either end that allow us to fly to much higher altitudes. But this particular COA is set up for 700 feet, per the FAA requirements for a BV loss flight for these particular platforms. Crayley?
Right, yeah. So I want to make sure that we talk a little bit more about both COAs and waivers, because I think that's really important in using Droneports for research. It's one of the things, obviously, that as a private company attracted us to doing projects here. Working with OSU is that their Droneport was able to provide us with some ready-made COA coverage for research. And then, of course, they have expertise, and we've developed a lot of expertise in the Part 107 process. So one thing I want to mention while we're starting this discussion is that if you have questions, do please post them to the chat, and those will be relayed to us. We'll probably take a look midway through and see what kind of questions are coming in, and we'll definitely take some time at the end to handle questions, but absolutely feel free to provide some questions. So when we talk about this particular Droneport, we are using it in this example project I'm going to talk about. And Jamie, I'd really like it if you can provide some additional projects. I know you all are doing lots of projects out there, and maybe if you want to characterize 3 or 4 of those, but I'll talk real briefly about this project just to get us started. So this is from a recent flight test in which Vigilant Aerospace is working with research engineers from the Unmanned Systems Research Institute to test integration of radar and other sensors into a detect and avoid system, which is based in software. And it takes data feeds really from as many sensors as you want to add. But in this case, we're particularly testing radar. And you'll see that small box, which I'll show you some more detailed pictures of. But that's a small portable radar, and we're really excited about that. That's an Echo Guard. They also have an onboard version of that radar, and so we are developing the path to being able to use that onboard with our flights so that we have a fully portable system, but we're testing it right now on the ground. And so we have some support from the state of Oklahoma for these particular flight tests of this software that's already developed, but we're integrating new hardware into it from the Oklahoma Center for the Advancement of Science and Technology. And so that's been great for us and great for OSU to do this kind of research. And so we were out here on a pretty blustery day using that radar to track an unmanned aircraft. We do flights with both multi-rotors for certain types of flights, and then we also do much longer range flights like the 18-mile flight that we carried out late last year with Jamie's team with fixed wings that have much longer endurance and range. And those are great aircraft for demonstrating what you can do in this kind of environment and really going beyond visual line of sight so that you can demonstrate that your system can provide coverage, safety, awareness of manned aircraft, manned traffic alerts, and then ultimately actually provide automatic avoidance advisories to your pilot and eventually maybe to your autopilot. So that's where we are. All of the regulations around that are developing quickly, and using this Droneport allows us to, use the regulations as they exist today and the capabilities as they exist today to really push to the boundaries of the frontiers of both the regulations and the technology, and do some unique work that's getting us to the point that we'll have this onboard detect and avoid system, and eventually what I like to call automatic DAA or ADAA for a fully automatic system, which is really what our software was designed to do by NASA. And so that's this example project that we'll use in some of these discussions. Jamie, do you want to talk about some of the other work that you all do? And maybe I'll advance a photo or two here.
Sure. Yeah, and we've done a number of other related tests at this particular site, including emergency first responder delivery. Primarily, again, you're looking at pushing the boundaries and the capabilities to be able to use the BV loss waiver to be able to test capabilities to deliver supplies to first responders directly in the field. Other tests that are similar of this nature includes projects that we're currently doing with the FAA for ILS and other nav aid inspection, which is tests are done here as a precursor primarily before we move out to operational airport facilities. Those tests are currently being conducted at Stillwater Airport. And then visibility tests for primarily determining the capability of pilots to be able to see UAS potentially operating in ATC operations, particularly smaller quadrotor style drones, which are the predominant form utilized by most consumers, but as well as fixed wing aircraft. And so that's both with and without nav aids, such as the capability of adding ADS-B or other detect and avoid systems that are then reported back to the pilot, and how adding those additional capabilities will enhance the safety of manned aviation.
So there was a lot packed in there, Jamie. I'm going to unpack just a little bit of that because I think you hit on several interesting topics. Jamie mentioned ATC, so he's talking about air traffic control. Something that I think is very interesting about Droneports and that we've heard over the course of these seminars today are about people that are using unmanned aircraft of both a larger size, like some of the things that Tom Sawyer does up at Grand Sky, in which you're flying larger unmanned aircraft, military development aircraft, and those are interacting with air traffic control. So there's someone who is responsible for talking to air traffic control and flying those with direct integration to manned aircraft. And then, of course, you have operations that are of smaller UAS, under 55 pounds, usually flown under Part 107, which is the rules that have been so exciting over the last couple of years to allow us to fly small unmanned aircraft below 400 feet. This particular drone port, of course, has a COA so that we can fly below 400 feet and fly under Part 107, or we can fly in different operations under as a public aircraft under Part 91 for the rules for a public aircraft, and then use that COA up to, I think it's 699. Is that right, Jamie?
Correct.
Yeah. So there's capabilities. And that's great for us because it allows us to demonstrate our system at different altitudes. We're trying to develop a system that's capable for both smaller and larger unmanned aircraft. It was initially tested, and we've done some testing with NASA on the Icona, which is a Predator B, which is a large unmanned aircraft. And then, of course, we also support operations with much smaller unmanned aircraft. We've used our system down to the Phantom 4, including specific encounters that were carried out here with the OSU team. This particular photo is of a recent flight of a medical supply delivery drone. It's got that MaxQ, that little blue box on the bottom, that is actually another OSU spin-out company that has a temperature-controlled and monitored medical delivery payload system, which was just fantastic. And so we were providing the flight safety, so the air traffic awareness for this flight to demonstrate that system. And so that's been great for us to be able to participate in. And that's one of those aircraft that is a Part 107. It's below the 55 pounds, but it's a VTOL, and so it's got the capability of going longer distances, but taking off and landing anywhere. And so it's been great to work with USRI and some of their outreach to other companies that have really cool stuff going on, and then cooperating with them to make this kind of work happen. And so the Droneport serves as kind of a community touch point where multiple companies can collaborate immediately on projects, and all the capabilities are there, the expertise is there. You have academic and research engineers who can bring a lot of capabilities in a very short time frame. You have the COA in place, you have expertise on Part 107 and Part 107 waivers, and then you have companies like ours that bring specific advanced technology that's really trying to push that frontier again to the facility and to the operation for other companies that are also doing innovative things. So this was an exciting day. We've had several flight tests like this.
Greatly. We have an attendee question. I don't know if we want to jump into some of those now or save those for later.
It's okay with me. Yeah,
Yeah,
absolutely.
yeah. Let me read the question. You can start the answer then. Do you have a sense of demand over the next 5 years for drone ports to serve public safety sector, ag sector, last mile delivery sector?
Yeah, so this is this is an interesting area. We're involved in some UAM and AAM programs that NASA is developing to provide some leadership and community leadership. So AAM is advanced air mobility, UAM is urban air mobility. Most of those types of operations and the sort of economic research that's going on around demand is focused on urban delivery and then focused on air taxis, particularly in urban and suburban environments, and then focused on more rural and agricultural uses of unmanned aircraft. Um, and so we expect that as the regulations change, demand is going to go up a lot. We are definitely seeing a use for drone ports where you have last mile delivery, or even more in the intermediate term. So, maybe a few years from now, you'll be using it for direct to consumer last mile delivery, which is when we think about the Amazons and the UPS flight forwards and the Google Wing project. All of those are mostly focused on direct to consumer last mile delivery. And so you're going to need somewhere for those to take off from. Maybe it'll be a van. Maybe it will be a direct warehouse facility. I know Amazon is thinking about using some of their warehouse facilities for direct to consumer delivery. But in the even shorter term than that, you're really going to need somewhere for hub and spoke style cargo delivery of larger unmanned aircraft, of which there are several being developed, where you have a pilotless delivery aircraft that is taking goods like like a caravan style Cessna Caravan that is popular for this, out to the local facility where it will then get distributed maybe by van. But those are flying all the time now. And the economic impact of making those unmanned so that you can reach more communities faster and much cheaper could be huge. So I definitely see that as a driver for Droneports, which is why we're racing to get our system installed at places where it's likely that you're going to want to have one of those nodes on that kind of network. So I'm not going to talk about the specific numbers because I don't know. I don't think anybody knows exactly what the numbers are. We do look at the FAA's forecasts, and NASA has also done a couple of studies that we can provide some links to in which they're specifically talking about UAM flights. But we see drone ports evolving from small facilities for smaller unmanned aircraft upwards into much larger facilities for more of the delivery aircraft. And the economic impact of that would be immediate because you already have those flights going on now. All the budget is allocated for that type of flight. It's just that you make it unmanned. And you really have to have systems like the advanced technology that we're developing here, with the support and cooperation from OSU to be able to have those aircraft fly safely and be aware of all the traffic, both on the ground and then also continuously on the aircraft. So we feel as that technology emerges and the regulations change, that's going to be where the earliest demand is. Jamie, did you have some thoughts on that too?
Oh, sure. Yeah, I'm always happy to add to that. I mean, I pretty much agree with everything that you said, and second the notion that first we have to say basically we don't know because it depends upon a lot of big what ifs, and things are going to evolve very quickly, over the next 5 years as both the bounds of the regulations and the technology are pushed. But we do have hurdles in both those areas that we have to overcome. Before these things become an actual reality. And, I really kind of foresee that we'll have, just like we have different categories and classes of airports that really serve different customer bases, from your large international airports and regional airports, general aviation airports, and then your private and ag facilities. That each one of those really serve a different sector. We're going to see things really emerge similarly in the Droneport capabilities, dependent upon what individual regions, what their needs are for drone and unmanned aircraft operations. Certainly, solving that last mile problem is going to have a very different drone port infrastructure requirement than what you're going to have with agricultural operations. I think you have to be prepared to be flexible in terms of what these facilities are going to look like and where they're going to evolve. Locations are going to be heavily dependent upon your topography and your population in that surrounding infrastructure in terms of what those needs are, particularly for that last mile problem, where I think we're going to see the most capable use of the UAS in the near future.
So, Jamie, related to that, let's talk a little bit about the top concerns in developing and operating a drone port for R&D purposes, and then eventually expanding beyond those purposes. I probably would put being aware of your airspace and then being aware of what your permissions are and expanding those at the top of my list.
Yeah.
How would you think about those concerns?
Well, first, I always like to remind people, when we talk about drone ports, very similar in terms of development of manned aircraft and airports. First you had the aircraft developed, and it wasn't really until about a decade later, after the development of the Wright Flyer, that you actually started to see airports pop up across the country. You didn't see airports in really any large number until during and after World War One, where you really started to see air travel start to come in on its own. And that's going to be very similar on the drone port side. But certainly in terms of the technology, to be able to make this thing feasible, we have to have that unmanned traffic net management system in place that gives us situational awareness, both drone operators as well as manned aircraft operators, about where those unmanned aircraft are flying and what their flight plans are. So that way we know that we can clear the airspace and make sure that the airspace is going to be safe. So when we start looking at the operational requirements for the research and development side, and that's clearly where we're at right now, I don't foresee any current commercial viability for a drone port in the current regulatory framework, because certainly everything is still operating under Part 107 waivers. But as that, those regulations are pushed, as we start to be able to make the safety case, then that starts to open up the sky. But really, in terms of operating drone ports primarily for research and development applications, obviously you're looking for airspace that gives you a lot of room to breathe in terms of making sure that you're not endangering the airspace with your R&D operations. So typically, these are going to be in rural locations, with a lot of space around them, both in terms of developing VTOL and rotary wing vehicles, fixed wing vehicles, and the capability to put in different detect and avoid systems, be it radar, visual-based systems, or other types of technology.
Right. So, Jamie, you said something interesting about UTM and how critical that is for the development of the industry. You and I had the chance to collaborate on a paper for the AIAA, American Institute of Aviation and Astronautics. And that paper was specifically about this project in the context of developing UTM systems. That was in the title of the paper. And so I wanted to talk just a little bit about what UTM is and how drone ports can contribute to the development of UTM. And then I'd love to talk a little bit about corridors and Part 135, because I think all those things are embedded in some of the things that you just said. So UTM, in case anyone doesn't know, is unmanned traffic management. It's the idea of having, as some other speakers have talked about in these seminars today, having an automatic traffic management system for unmanned aircraft, particularly those flying below 400 feet. It's something that came out of NASA. It's a concept that NASA has been developing and that the FAA has made a commitment to and has a team that's working on. And that UTM concept is turning into a series of rules and protocols about how unmanned service suppliers, so private companies that would, just like a cell phone network provider, would talk to each other and allow you as an unmanned aircraft operator to talk to the network to coordinate your traffic. So you would tell it where you're planning to fly, when you're planning to fly, and it would connect you up with the system and say, yes, that's authorized. We're aware that you're doing that. Go fly. And then if something changes, an emergency aircraft has to fly through, the system would notify you, maybe notify your aircraft. So the idea is having lots of autonomy in a UTM system. So we're really excited about that. Part of this project is aimed at enabling part of the automatic part of that, which you absolutely have to be able to automatically be aware of the traffic and then to avoid conflicts, particularly between unmanned and manned traffic, but eventually between unmanned and unmanned aircraft automatically, and maybe eventually manned aircraft, so air taxis or even manned aircraft having additional capabilities as part of new deconfliction and collision avoidance systems. So UTM is really exciting. It is something that we're really very interested in. It's one of the reasons that we're developing this. Something else that we mentioned a little bit that I would love to have Jamie elaborate on a little bit is the idea of a corridor and how that fits in. And in fact, I'm going to jump back to our picture of the COA, because that forms the basis of a corridor here in central Oklahoma that could be very impactful for all of this commercial development. So Jamie, tell us a little bit about why this permission area is long.
Sure. Yeah. And obviously, this corridor is really set up for research and development purposes, because if you look at it, it kind of goes from, if you look at a regular map, it kind of goes from nowhere to nowhere. But that's designed on purpose because we have a flight test facility located on the southern end and then a flight test facility located on the northern end. And there are different sets of COAs on both ends, for different operations that allow us to, fly within one COA and then transition from that COA to this BV lost COA, depending upon what particular mission that we're flying and what technology that we're testing. But the goal here is to be able to really show how far you can fly under BV loss conditions. Using your pick, your pilot in command at one location, and really be able to fly airport to airport. And the reason that this particular COA is shaped like it is we want to be able to fly from the runway at the south field to the runway at the north field, or in the case of our demonstration, be able to fly there and back again. Essentially, fly from one end of the corridor to the other end, turn around, and then come back. Again, extending that capability to show how far you can actually operate. Now, there are a number of corridors. There are at least a handful of them, across the country now, that are really designed for specific applications. Some follow infrastructure. So if you're looking at, wanting to test infrastructure, inspection systems, flying and having a corridor that flies directly over a set of power lines, essentially shadowing that, give yourself about 100 feet off the top of that. And as an example, of another BV lost corridor that's currently being operated across the country, really to be able to test that certain, type of inspection system. Our corridor is fairly open, so there's really nothing in between those two. You do cross a highway, so you have to ensure and make that safety case when you're getting permission from the FAA to be able to do these flights and get this corridor approved. But again, the purpose of this particular one is just purely for BV loss research and development.
Right. So corridors. Oh, go ahead.
I'll just say eventually, what we'll have, obviously, when we start looking at UTM, I anticipate that we'll have real corridors first, that will be permanently fixed in place. For example, connecting one city in the southwest to another city up in the northeast. That would then allow pilots to be aware that there's a potential for unmanned traffic operating within that corridor. And that's particularly useful for, point-to-point types of regular deliveries. But, the whole point of the UTM system and capabilities is to have these corridors set up virtually and, quite literally on the fly as you're, putting your flight plan in place. Sorry to interrupt you there, Creighton.
Yeah, no, that's great. And that's just what I was going to emphasize, which is that, the point of the corridor and having these special permissions is to allow us to model flights that eventually will not be flown in a corridor. I mean, the point of the corridor is for it to retire itself eventually. So that the corridor allows us to do things that are special and advanced now, and to be able to develop things and demonstrate them in a way that is very safe for the airspace, but with the idea that we can go the same sorts of flights and the same distances using the same systems that eventually will be done either outside the corridor or within corridors that are passing through controlled airspace and that are passing through urban areas where you have more ground risk, and you've got to be flying an aircraft that's safe for that with a system that is safe for that. So this is extremely valuable, I think, to us, extremely valuable asset to Oklahoma. And it's something that that this flight station contributes. So not only to university research, but really to commercial development statewide and nationwide. I know Jamie has a lot of people that come and use that facility and a lot of research that they do. He mentioned some of the types of research, but a lot of those researchers, of course, are coming from across the country to work with OSU on these types of projects. And this corridor really helps with that, and we're excited to potentially see it extended. And as we develop and deploy our systems, we feel that those capabilities will be there to provide that safety and support for extending this corridor and other corridors like it into controlled airspace. Let me jump ahead here just to a few more of these photos. This is a photo of us actually using our system during one of these flights. This is kind of what our user interface looks like, and you've got some information on the screen there based on the regulations and what aircraft is allowed to be where. There's a picture of the whole team on one of those flights. Jamie, were there any other questions? I had another couple of topics I was going to jump into.
No, I think you're good to go.
Good. So I was going to talk a little bit about Part 135. We've talked about Part 107 and Part 91. And these are regulatory topics that are really important in using Droneports. So Part 91 is when you're flying as a public aircraft, and so as a university research aircraft, for example, or a government aircraft. Part 107 is when you're flying a small unmanned aircraft, which is great for surveying and taking photos. And there is a path to be able to get waivers to fly that beyond visual line of sight. But one of the really exciting developments over the last year or so has been the use of what's called Part 135 for air carrier classification of your unmanned operation to carry cargo. It's very early now. Just a few organizations that you all have heard of, I mentioned some of them earlier, are pursuing that route. So we're excited to see that. We will hopefully be making some announcements as a company about that over the next few months, and some opportunities we have involving Part 135. Jamie, I'm sure you're following this closely. What do you think about the use of Part 135 and what that's going to enable the industry to do?
Well, yeah, I'm pretty excited about that. Again, that opens up a lot of possibilities in terms of being able to actually test the systems and really do demonstrations. If we start thinking about this from an economic viability, we know the technology is feasible. But it's proving the safety case to the FAA, and then obviously proving the economic viability case to the marketplace. And cargo delivery, being able to do this safely yet efficiently is really going to be that linchpin that makes this technology successful. And the Part 135 operations are a step to be able to do that.
Right. So Part 35 is really being adapted away from all the regulations in Part 135 around manned aircraft for cargo delivery to be used to go down a waivered path to use unmanned aircraft for delivery. So you have to waive many things in your operation. You have to get waivers for many parts of your unmanned aircraft operation to use Part 135. But the result is we hope that you're going to be able to have more routine cargo delivery using unmanned aircraft. And eventually, we also expect that there will be rules specifically for unmanned aircraft to do cargo delivery. And drone ports, I feel, form a nexus for that. They're places where you're going to have all the components that you need to be able to develop a Part 135 operation and do it much more quickly than starting, in the middle of nowhere. As Tom Sawyer said in the prior session, starting with an airport, particularly when you're talking about larger aircraft, might be a good way to start. And I really agree with that. The great thing about a drone port like the one at OSU is that we can bring out the equipment that we want and need and place it there and use it there under the existing permissions that they have. And then, expand that into commercial operations at lots of other locations relatively quickly because we will have fully proved it out there. So that's one of the things that's great for us. I've got a few more photos here. So we talked a little bit about our system and what we're doing, and I'm just going to go over it in a little more detail because I think these things are all components that are really necessary for the commercial use of drone ports, and that's why we're doing this. So you'll see in this photo, this is conducting one of these flights. I've already pointed out a couple of times this radar. The nice thing about the radar, which is the box on the right-hand side, that's an EchoGuard, which is a ground-based version of the Echodyne radar, but it is very similar, almost identical to the Echo Flight radar, which we are working on integrating into slightly larger unmanned aircraft. And that's going to allow you to carry this with you. So you'll be able to use the full corridor with a radar like this. Some other operations, like the operation Tom was describing, which we also intend to support operations like this, are using much larger ground-based radars that go much longer distances in terms of their detection of manned aircraft, so 20 kilometers to 60 kilometers in some cases. And that allows you to operate from a single facility out either along a corridor or over a much longer distance with that ground-based radar. And then, of course, the portable radars, which is what this particular setup and test is focused on, will be able to travel with the aircraft. Also in this picture, you'll see another antenna there in the middle of the screen, and that is your ADS-B receiver. ADS-B is a protocol for manned aircraft to broadcast their position continuously. So about once a second, they provide an update of where that manned aircraft is. In the United States, starting in January 2020, manned aircraft that flew in controlled airspaces at any time were required to have an ADS-B transponder, and that makes it really convenient for unmanned aircraft operators to be aware of where manned aircraft are located. When we use this particular drone port and do these types of tests, we see continuous manned air traffic. It's very far away from us. The range is very long on this receiver and on those transponders, but it's great because we can combine that in our system and have visibility. And I know Jamie has a lot of experience with these types of systems and combining ADS-B with other tests. And then the third thing I'll just point out here is that OSU and this drone port provide us with support and access to their aircraft. And so they have pilots. In this case, they have a ground control station that they use that we pull data directly off of so that we have telemetry continuously from the aircraft in addition to these other data sources. And that allows our system to pick up all that data, track within a few meters or just a few feet or less in some cases exactly where that aircraft is at all times, and forms a baseline for our research. And so OSU and this drone port provide that to us directly, as other drone ports would be potentially capable of doing. And that's a facility that's extremely useful for R&D and the development of this technology, is to have that as a continuous baseline, just as a part of every operation that they conduct. then they have a wide variety of aircraft, and that's also really helpful. Jamie, do you want to talk a little bit about some of the technical facility that you all provide, from aircraft to systems to expertise?
Yeah, and I don't recall if you have anything in the slides there to help support any of those, but we operate a number of different aircraft, from small commercially available systems to a number of custom rotary wing and fixed wing systems. For this particular facility, mostly focused at the SUAS less than 55 pounds, but some operating up into the hundreds of pounds, depending upon the requirement. One of our focuses here is obviously, besides beyond visual line of sight testing, and supporting that detect and avoid capability. Looking at different systems and trying to make that safety case, is supporting other tests, such as the recent NASA University Leadership Initiative, which both Vigilant Aerospace Systems and OSU are part of, really focused on utilizing drones to enhance aviation weather, real-time reporting and forecasting. So we do a lot of weather observations here, both within the ABL and up to, atmospheric boundary layer, I should say, kind of that lowest region, up to regions beyond that too. One thing I want to go back and emphasize what Crately was talking about in terms of some of the systems that he showed in some of the slides. If we talk about Droneport capabilities, they're obviously kind of the obvious infrastructure facilities that you're going to need to have in place, some of which might already exist at existing airports, that you think about turning a manned aircraft airport into a drone port, such as runways and hangars and power and the like. But it's really going to be those smaller, more novel facilities that are really there to make the safety case through detect and avoid, that serve as the eyes and the ears for the unmanned pilot. So those are the things that when we talk about drone ports and the technology that really need to be developed. So we do have a couple of questions here, Crately. So how about I read these out, and then you can maybe shoot off an answer with some of these. Can you speak to accomplishments of research and development drone ports outside the U.S.? And I'm not sure if I can on that. I'm familiar with some non-UAS UTM research. Most recently, some stuff that's been done in Ireland and in France, but to be honest, not much beyond that.
So, yeah, there's a few things. Both of those are interesting, Jamie. Of course, there is very interesting development going on outside the U.S. in Europe and Asia, particularly, and then there's fascinating stuff going on in Africa. So I'll just run through a couple of projects really quickly. So the USpace system is an implementation of UTM and is in Switzerland, where they're really trying to advance this quickly. They're really trying to be a European and worldwide leader. And so I'd urge you to look at that if you're interested in what's going on internationally. The Global UTM Association, GUTMA, has conferences, and a lot of members from the US and other countries participate in that. There's an effort to harmonize the UTM systems and standards that are developing internationally with what's developing in the US, and also being developed by ASTM, which is a technical standard writing body that I've spent a lot of time with, helping with detect and avoid standards, and now with testing of detect and avoid system standards, and then supplemental data for UTM systems. And so all of those standards have to be harmonized and synchronized with the standards that are developing internationally. And so there's a real effort to do that. And so that Global UTM Association is one of the leaders of that. So Transport Canada, I know, has authorized some advanced delivery flights, and we know people that participate in those, particularly from Alaska, that are going over the border and doing some advanced operations in Canada. They got a lot of open space there and a lot of exciting stuff going on. And so that's great because that seeps back over the border. That expertise comes back to us and we can use it as we develop those types of operations in our more congested airspace. In addition, of course, Matternet for a while has been doing deliveries in Europe and Africa. And Zipline has been doing medical supply delivery. I believe they are also in Switzerland. They've had some operations. And all of them, some of them are working out of mobile drone ports and some of them are working out of fixed facilities. But all of those groups are working internationally. I'll tell you, we're talking to several groups, particularly in Scandinavia. There's a lot of advanced operations there. And some companies that have particularly software and systems and manufacturing in Scandinavia have also set up joint offices here in the US in a variety of places, particularly North Dakota. And so they have a lot of interest in our system because they're trying to fly offshore in the North Sea. A lot of that is search and rescue work. Some of it is offshore platform for pipeline inspection back and forth from platforms, and then drilling in operations. So all kinds of stuff offshore in the North Sea that's developing pretty quickly. And those will be from a variety of facilities, but they're coastal facilities that'll be flying those aircraft. And I think they're going to start with search and rescue as one of their higher priority operations. And then the delivery of emergency medical supplies and other things like that to platforms that are otherwise isolated. So those are just some international operations that I'm aware of. And I don't necessarily have the names of the facilities that they're flying from, but I'm familiar with some of the airspaces they're flying from. So they're flying under new EASA regulations, which is really exciting. They were supposed to be published in July. They got pushed off to the end of the year, so January 1. There are going to be new EASA regulations on drones for beyond visual line of sight available. And we're working with a couple of different organizations on utilizing those rules with our systems to be able to allow them to fly primarily out of Scandinavia, and a lot of that's going to be offshore, but some of it will also be urban in Holland and some other places. So that's just kind of a smattering.
Yeah, you mentioned Holland. I mean, there's the Droneport EU, which I think is in the Netherlands.
Right.
Yeah, and they're doing a lot of great stuff. I think that's a former military facility that they're currently operating out of. And even though the airspace tends to be a little more congested in Europe, they've also been a little more flexible, in terms of opening up parts of their airspace to drone port operations, primarily for R&D purposes.
Right. The other thing I'll mention is that there's interesting stuff going on in South Korea. There's interesting stuff going on in Singapore. In Singapore, they've been working on testing some delivery corridors going between both university facilities and warehouses, hotels and university facilities as kind of a delivery experiment. A lot of activity around that. And then they've been doing some offshore work where they're doing deliveries to and from ships. And so in Asia, they're one of the leaders. And then in South Korea, there's development of some drone ports. I think the pandemic has probably slowed down some of that development, which is unfortunate. But I do know that there's a lot of effort going on with government backing in South Korea. So we've had some discussions with facilities about the development of those drone ports. So I wanted to take an opportunity in our last few minutes here, Jamie, to certainly any other questions are welcome, but I wanted to talk a little bit more about the NASA ULI and the weather research and how that fits into advanced air mobility and the use of drone ports and what NASA is trying to accomplish with that project.
Yeah, certainly. I'll just jump in on that. For those not familiar with the NASA University Leadership Initiative, aka ULI, it's a recent program that just started several years ago outside of the NASA's Aviation Research Mission Directorate, really to jumpstart university industry collaborations, focused on NASA aviation research areas of interest. And since NASA has been, determined to be the tip of the spear for the unmanned traffic management system development, primarily coming out of NASA Ames and then married with their long aviation history, this particular project, which we call WinMap, which stands for Weather Intelligent Navigation Data and Models for Aviation Planning, really fits within NASA's wheelhouse and is greatly in NASA's wheelhouse. And as Crately mentioned, this is really a nice marriage between what the universities are doing on the academic side and what companies like Crately's are doing on the technology transition side. Being able to get this technology within the hands of, eventually the Droneport operators themselves. And our focus is really on, solving that problem, which is, not a big one right now. If you're doing drone operations, typically, you're going to be doing this for, say, commercial photography, flying under Part 107, limiting yourself to, visual flight operations. And when you can't meet those conditions, you just don't fly. But if you're doing, cargo delivery missions or, other types of missions such as, first responders, then you really can't limit yourself to only flying under VFR conditions. You have to be able to fly, when you cannot see due to weather, but also being able to operate, within confines of, say, high wind operations, particularly in urban areas where you might have things such as urban wind canyons, which are very difficult to predict. So this particular project is focusing on getting real-time information from UAVs as they're operating and sending that back to a weather information network that provides that up-to-date weather information to other pilots in real time, and then uses that information to provide better forecasting so that way you have a real-time forecasting capabilities. And these systems will then be integrated into Flight Horizon so that way, in addition to the drone operators knowing what those potential manned aircraft hazards are, they'll also know what the potential weather hazards are going to be.
Right. We're really excited about this. We're excited to be the commercial partner and the UTM provider for this project. This project has big implications for how you safely fly unmanned aircraft. And so our goal is to be able to display and allow you to automatically avoid not only obviously manned aircraft and other unmanned aircraft as they enter the system and can be tracked the same way that manned aircraft can, which remote ID is going to pretty quickly allow. And then an overall UTM system will also be tracking all of those unmanned aircraft to then overlay and add to that weather hazards, including micro wind hazards, so small updrafts and other things that are very dangerous for small unmanned aircraft that might be a few hundred pounds, might be delivering critical cargo over a city or a suburban area that can be very vulnerable to those weather hazards. So that's exciting for us. We're expanding what we're capable of doing, and that should be a really interesting project to continue to use this Droneport, work with OSU, and make that happen. I'll mention another project really quickly as we're winding up here. We have a contract with the FAA to provide testing of radars for deconfliction for unmanned aircraft. This is a unique project. We're really excited about it. We're testing a wide variety of radars directly integrated into our system. We're hoping to use some of these onboard radars and demonstrate how those work, and then provide really detailed data to the FAA and have those integrated directly into our system. We're working with the Droneport at the University of Alaska Fairbanks, which is part of their unmanned aircraft testing center up there. They have one of the UAS test sites. And so that's an exciting project that was awarded by the FAA. So we've got another question here, Jamie, which I'll ask you really quickly, and then I think we've just got another 3 or 4 minutes. As the pandemic continues and budgets become even more limited, do you find that OSU and other higher education institutions are cooperating and collaborating more than what they may have been doing in the recent past?
Yeah, actually, I don't think the pandemic has really impacted us in that way, one way or another. Obviously, we've all moved to virtual meetings and virtual communications, so we've been having lots of those. But unfortunately, I think it's been overall detrimental to research and development. Not just in the unmanned aircraft space, but research and development across the entire scientific and research enterprise, not only in the U.S. but throughout the world, since it has hampered the ability for people to actually have not only face-to-face communication, but also working in a laboratory environment. We're pretty lucky in our sense that we do a lot of our exercises and tests outdoors, and so the pandemic has really not had much of an impact. Although it doesn't matter, if you're outside in flight testing in Oklahoma Day in August, you're still wearing a mask. So that's problematic. But there are many federal research facilities and other public institutions that have been shuttered, and all their research and development has gone virtual. And without the ability to actually go out and test, that really limits what you can do. I mean, to prove that this stuff works, we have to put aircraft in the air and have hardware on the ground.
Yeah. We've been obviously very lucky that a lot of the work that we do with OSU is outdoors. They've been very accommodating, and we've been very careful. You saw in some of our photos that we have a lot of practices and rules that we follow when we're doing this. But really, that ability to put aircraft in the air is just unsurmountable. You have to be able to do that, and that's where drone ports are so critical right now. I mean, they're really more critical now than maybe they'll be in the future when they're more prolific and they're used for more kind of mundane commercial purposes. We've got to get the systems in place, and drone ports, are a really important part of that. So that's something that we see every time we do this, and we go out every really couple of months and do a major flight test, sometimes a little more frequently and sometimes a little less. But we're out doing this with the real systems, the real aircraft, and people who are users of our software. That's the nice thing for us as a commercial entity, is we have real users who are unbiased and get to see a lot of different systems on a lot of different aircraft in a lot of different situations, and can provide immediate feedback to us with a mix of expertise. Some of them are very expert, they're research engineers, and sometimes we'll have undergraduates who can come out and observe and provide their feedback as well. So that's been great for us. I think Sally is ready to come back into our session here in just a moment.
So there was a question here about, just one last question real quick, asking about most of the work will happen within the U.S. And that is correct. The majority of our flight testing happens within CONUS. And same for you, greatly.
Yeah.
All right. So sorry about that, Sally.
No problem. Thank you, gentlemen. We have a lot of thank yous. It's really been an incredible day. We've all learned together. So the attendees, our staff, our speakers, and everybody supporting us, it's all been learning as we adjust to doing what we do virtually instead of in person. So I miss seeing everybody in person because I certainly like those hallway conversations. But we're glad that you were here today with us. Our speakers are always so giving of their time and their expertise, and that makes our jobs really, really fruitful, because we learn every time we get to hear some of our speakers share what they know. And to the folks at AUVSI for being such a great partner and enabling the Droneport Network and the UAS Cluster Initiative to do a co-located event. It's kind of like us being able to bring content to folks who are already doing something in such a big way. Part of your registration also gives you access to the Expo Hall Pass, and I would say get in there and check out what is going on. Last year in Chicago, we actually got to try out and sit on, not fly, but sit on an autonomous Bell helicopter, which I have to say that my kids and grandkids thought was a pretty cool thing. So you never know what you're going to find in the Expo Hall, and I would encourage you to do that. We will make these recordings available. It will be available on this platform. It will also be available after we've been able to edit it on the Droneport Network website. So that'll probably take us until next week on the Droneport Network website, and I think that it'll be available on this platform much sooner than that. We thank you again and hope to see you soon at an event coming up.